Hello Earth, welcome to episode 31 of season 3 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. If you're just tuning in for the first time, I recommend you go check out github.com/outthecodenl/cell, link in the description. So I made a bunch of notes just before starting the episode. They're here. And I have an upcoming sequence of work here, which I am, I'm recording. So yeah, I'm recording here in the couch, being very lazy. But not so lazy that I'm not recording at least. So I want to rework the entry point of native calls, if, do, and put, basically. I was already trying to get put to work. Put was working, but then I decided to have a single way of running code where I just basically put the incoming call in the data space and then let that get a result, and then I just return that result. But then I realized I never had done a put, like I had never put a put in the data space, if that makes any sense. I was just making the put at the outermost level and then getting the side effect and just moving on. But we don't support putting put inside the data space, which is actually an interesting omission on my part. But not anymore. But then I was realizing that no, I want to open the actual code for cell. So all of this stuff, this is the cell.respond function, right? Which is this is cell code, which is what I was rewriting. This is the old way. This is a new way, which seems to work a little bit. At least a few tests were passing, right? If I remember correctly. Yeah. It doesn't matter because this is more like further down the chain. So I want to get rid of this code really. And I want to basically have this stuff here. So let's just understand what this code is doing, because I want if and do to be inside cell.native. So I want to do all these refactors, but I want things to work. So what I'm going to do is I'm keeping the existing set of tests, and because I want to rewrite the tests, of course, but I'm keeping the existing set of tests and trying to make them I'm going to make them pass again, changing the implementation. So this is like if you have 2 feet, you can move forward by just standing on one of them. So right now I'm lifting the code in the air and the tests remain in the ground. And then once we take a step forward, then I can rewrite the tests. So yeah, that's what we're doing right now. So current value, let's just look at the annotated. I'm not entirely sure if I can do as a native call. I think I can, honestly. But yeah, I think I can. I will be so much cleaner, because if you then read from the top, you find the leftmost, the rightmost add, then you basically set the rightmost add to the rightmost add do that you find. The rightmost, right? Yeah, because I'm going left to right. No, the leftmost. So you freeze it at the leftmost add do, and then you just set variables, which is context path is to the left of the leftmost add. Target path is all the way from the beginning to the rightmost add, plus and equals, which is where you're going to set the stuff. And the value path is whatever is to the right of the rightmost path. Yeah. So whatever is to the right of the rightmost path, I'm jumping over the equals, basically. Let's read that definition again, because I'm still confused by it. I still don't fully get it. Anything that is not a reference is a context. Target path is everything to the left of rightmost path. Rightmost path plus an equal. Good. This is the common prefix of all the paths we're going to create or update. Yeah. The right part of the assignment, okay. So get a way to call this go get is as jumping over equals. Yeah. Yeah. And now we're dealing with the call. We just basically do the code, the logic to see if this is the first. Yeah. The prefix. Yeah. So first path. If there's no previous path, or if the previous path has a length, and prefix, what do you mean? Length smaller than prefix than that of the prefix. Okay, so we already do the first path logic here. Okay, I had forgotten about that. Good. So what I want to see if I can get rid of this and set this just to work. Current value, sure. Get the value path from this context path. And then current value length. So basically, if there's no value, I think I'm implementing the walking up here, right? Yeah. Yeah. I have a call here. Yeah, I'm still not getting what I did here fully. I'm not getting the mechanisms. I'm wondering how I can actually explain them to myself in a way where I can see them crystal clear. The context path I completely get. The target path is where I'm setting things. No, it's the left side of the assignment, I guess. Yeah. Yeah, and the value path, yeah. So yeah, left side of the assignment be like left side path, and then the value path is the right side. Yeah. So let's go with that definition. I don't understand why I'm passing this thing with definition path here. What do I do with this? What do I do with this? Because I'm executing a call. So if I'm going to put this record again from the beginning. There could be a sequence call in the value path. Yeah, I get it. Yeah, I need the LLM to give me examples that I can use. Let's see if the LLM can help me out here. The part after and let's see. Interesting. I picked this up from the README. I'm still trying to figure out ways to proactively use LLMs without turning off my brain. No, I don't like this. No, unfortunately, I don't like this. Unfortunately. So this one is waking up, finding a definition. And this album is really good. It's really good. First time I listened to it. Index is what? Yeah. So it basically yeah, so I basically go through the paths. The path being what? Yeah. All the paths. Yeah. Yeah, see this repetition here. It's just, I remember I did it, but I wasn't happy about it. Definition path. Yeah, because you have the add do here. I'm missing something here. I'm looking for a key that I cannot find. Maybe the key is in the examples themselves, right? If I look to the these are just the reference ones. The references are handled by they're also handled here, the references. Here we're trying to determine if there's no call, this is reference. right? Yeah. No, the reference is at the beginning, right? Yeah, what I need to do is take in examples that go in increasing complexity and just see how that reflects in the code. Otherwise, there's no way to understand this call. I will not get it. Yeah, see how this one already is broken because of the changes I did. Yeah, so what we can do is restore the old functionality. Yeah, that's what I had to do. So I'm going to restore this. Comment the comments, like who watches the watchman. So, and this section goes, and now everything's going to pass. Okay, now that everything passes, I'm going to understand it. So here cell.respond is not concerned because this is I am basically doing it straight up. And these tests, wait, these tests already count. I have like some basic tests here, and I don't understand how can anyone watch my videos because I'm all over the place. I'm so sorry, but I used to have well, I have some new tests, and while I'm not like super eager to get them going yet, they are clearer, way clearer. That's why I was writing them. So I think if they pass, I can actually infer the structure from there for the code. I can really understand how the code runs through them. Where is it? Yeah. Validator 5. Yeah, because it's so what I will do is I need to remove this. See how comments can be useful sometimes. This is a bit dirty, but it will work. All right. CT is yeah, because I want to do it with multiple lines, right? Get with dot. I think these ones were not these are just with multi-line, so nothing to do, right? Nice. Okay, now I have the old and new test working, simply by virtue of restoring the old code of cell call and removing a couple of tests. I forget, what was this? Yeah. All right, so, well, these calls yield errors, so that's why they work. And then put validations also are, so the puts are still like not, well, gets, these gets also are not running through cell call. I just realized, because I'm just doing straight gets in the old definition, right? Yeah, I'm doing that. Yeah, so look at this. Here I'm just doing straight up reference. But so yeah, in this case, how would it work if it were to be through, I mean, it's not going through the actual mechanism of cell.respond, but it could be, it will. So how would it do it? Let's just think it through. Let's say empty context, sorry, empty data space. Can do some comments here. It would be the leftmost at would be 0 because it's the rightmost at, it would be also 0 because the path is length of what, 1 minus 1 0 minus the index of the rightmost at, which is also 0. So that's not going to be changing it. So the context path would be, it will be an empty array. It will be empty. Well, that's actually I cannot say that it's empty, so there's no context path, so I can just be, at least you can do that without getting a syntax error. Tell me if you can do it in your language too. Oh, yeah, because an empty path is an empty text could still be something. Yeah, and the target path, it will be basically equal, and the value path, so 0 plus 1 would be 1. It would be, but it will also be empty because it's nothing. It would also be empty. No, wait. Path slice, rightmost at would be 0 plus 1 is 1. Yeah, we're slicing from 1 and beyond, but the path is really 0, so it's also empty. Yeah, we just basically are setting the current value here everywhere. You are not implementing the case of just pure reference here. This is madness. It's like it's not supported at all. Because we're always doing the current value, right? Yeah. Yeah. It seems it's crazy. We're not supporting it, I think. Because this prefix is 0 minus 1 to the whole thing. Maybe why do we assume that there's always a value path here? So let's just do this. Do I have a proper value path here? I didn't even write it down. Man, am I that sleepy? Value path is path slice 1. So slice 1, yeah. It's just ignoring the first element of the path, so but there's nothing, so it's empty. Nice. Yeah, this definitely doesn't work for reference. So it's already broken. And if I had a reference somewhere else in my calls, because I supported that, like for example, I had calls here that were getting stuff from different places. That's being supported in cell do. Where am I? Yeah, cell do. Yeah, cell get there. Cell get. Yeah, we're referring. Yeah, so that's how it worked. But now we need to do it differently. So I cannot go to the simple examples because it just doesn't make sense for now. I will need to go to basically sequences. This is too simple. This code was just all implemented straight. If I look at the tests that so all of this put with context path, put with dot, or should be, yeah, no, dot, of course, not dash. Okay. Yeah, we're totally taking the bull by the horns here with the language, because it is the real engine. And cell.respond was already pretty complex, pretty hard to understand, and you can see this distinction between native and non-native calls, do being here outside, not reusing certain mechanisms. This is wrong. Not wrong. We need to redo it, and it has to work. The good thing is we have the tests. There's some tests. When I'm explaining things like that, I feel like Ricky from Trailer Park Boys when he's explaining stuff. So I need to understand what's good with this thing before I throw it away. So this would basically work with still works, right? Did I break everything already? That's a bit fragile, huh? You know what? I should fix that already by doing this. Okay, it was valid. It was a valid objection. So if I go here, you need to understand when I'm starting to call here. We can do it here. What's the first call? So it starts with refu. Okay, that's the first call. Respond. It's not the put, it's this one. I'm setting a I'm setting a reference. So this is a reference. So that's one way to stop it. Okay. So I get that's the left side. The target path is where I'm setting the value, and the value path is full. The prefix is, what am I using the prefix for? it's neither of this for sure. It's just this one. I'm so silly. I'm really doing this here. This is it. But this is not going to support the other references I was doing. Right? This, I guess this deals with the case where value path is nothing. Ah, so it does support reference, right? I think it would, because let's say that prefix is if I would do this, and if I don't throw, I'm a bit lost here. There's too much going on. And these are the new tests, right? Yeah, I can comment those. Okay, better. Sorry, there's too many. Interesting how this is calling or recalling things with the same paths, right? Why does it happen so many times? See, maybe that's also the root of the inefficiency that makes it take so long to run a test. Like, I don't understand how this test can take 200 milliseconds to run. I don't get it. That's probably why. Just coming in on every index. Because it gets the whole thing. Actually, this should get and that and nothing else. You should actually get everything, not nothing. So that case doesn't even work. What was it? Foo? Yeah. Yeah. In any case, this is wrong. Well, not wrong. It's just, yeah, I need to redo it better. So in this case, I think it gets it from there, right? Yeah, but I need to throw later, right? Yeah, it gets it from there. So yeah, because it's getting the current value from the value path, which is foo, with the context that is ref foo. And ref foo has that because it's a foo at, well, actually it doesn't have it, it just goes up. The going up is done by cell get. Let's find that cell get. does that. This is a good record. So I'm trying a normal reference here. So you should start by doing a reference. What should be the algorithm? Development nodes. Respond, because put and get will just work in the data space for the self-similar. So the call, I think I did elsewhere here. Yeah, here. So this one, see? It should actually be like this. So respond. Yes, do if the get, yes, sure. So there's a walking up. Try first reference, then if you don't get anything like that, go up for each of this you walk up. So get does the walk up. It is the real scheme. Wow, this is really good. This is tough, but it's fine because it's I think it's supposed to be tough, this thing, right? It's really the parsing heart of it. Yeah. I just need to induce it from the examples. Yeah. So I'm going right to left, resolving the references as a mechanism. So references right to left. If you find a value that's greater than 0, stop. If not, go to native. And native can do native detect an if dispatch to it, dispatch detect, do definition, detect, do execution, detect another native call. If nothing yields something, give up. Native gave nothing, does nothing. I don't understand why this function needs to be so hard. I'm going to be giving it a hard look. I don't really remember the structure, so I have the context path, target path, and value path. Prefix is, yeah, it's a target path. Just say add and whatever is in your value path. And the current value, yeah, when there's nothing, that's the case of reference. You were trying to get an execution, if I remember correctly. Yeah, we're trying to find add do's. Yeah, you're trying to find calls somewhere else. References to calls. Yeah. References to sequence, sorry, not to calls. So reference is a call. Is a reference to a sequence. It's a special type of call. 3 types of call: reference and conditional. Reference can point to a sequence or a conditional. Not bad, not bad. All right. Loading up a couple more things into my memory. Why length 3? Oh yeah. When you have a longer reference, yeah, that's the sideways walking up for the references. Yeah, I need to make this explicit with examples. Otherwise, it's hard for even for me to follow. Get the message and then we execute. And if we cannot find a call, this is fine. We'll go to native. So this I want to move inside the other one. This I want to move these two inside native. And native, yeah, should have support for if and do here. Yeah. Yeah, this is gonna keep us busy. Couple episodes, but it's okay. I'm gonna stop for today. Thank you for watching.